Let's learn about nuclear chemistry. I present to you our group mates, which is Azri, Shafika, and Zaim.
Introduction of application nuclear method to chemical physics. First, let me explain about nuclear chemistry. Nuclear chemistry is the study of atomic nucleus, its reaction, and radioactivity. Radioactivity is spontaneous emission of particle and energy during nuclear decay. During radioactive decay, unstable atoms lose energy by emitting radiation. The most common type of radiation are alpha particles, beta particles, and gamma rays. Chemical physics. Chemical physics, defined as a sub-discipline of chemistry and physics that's discovering physico-chemical phenomena using techniques from atomic and molecular physics, also condensed matter physics. It is a relationship between physics that studies chemical process from the point of view of physics. Chemical physics is different from physical chemistry because chemical physics is more focused to characteristics of an element theories of physics. Chemical physics deals with the study of electron, nuclei, atoms, and molecules and their interaction between them. The current stage in the development of chemical physics is characterized by the extensive use of numerous highly effective physical methods that provide extensive data on the structure of the atoms and molecules to the mechanism of chemical reaction. These include spectral optical methods, mass spectrometer, the molecular beam method, X-ray diffraction analysis, and electron microscopy.
Radioactivity is a spontaneous emission of particles and energy during nuclear decay. Types of radiation are emitted by radioactive nuclei, or which nuclei are radioactive. During radioactive decay, unstable atoms lose energy by emitting radiation. The most common form of radiation emitted have been traditionally classified as alpha, beta, and gamma radiation. Nuclear radiation occur in other forms including the emission of proton or neutron or spontaneous fission of a massive nucleus. Radioactive decay will change one nucleus to another nucleus if the product nucleus has a greater nuclear binding energy than the initial decaying nucleus. The difference in binding energy by comparing the before and after states determines which decay are energetically possible and which are not. The excess binding energy appears as kinetic energy or rest mass energy of the decay product. Nuclear decay processes must satisfy several conservation laws, meaning that the value of conserved quantity after the decay, taking into account all the decay product, must equal the same quantity evaluated for the nucleus before the decay. Conserved quantity included total energy, electrical charge, linear and angular momentum, number of nucleons, and the atomic number. The figure shows about 137 barium decay data, counting number of decays observed in 30-second intervals. The best fit exponential curve is shown. The points do not fall exactly because of statistical counting fluctuations. In natural radioactive decay, three common emissions occur. When these emissions were originally observed, scientists were unable to identify them as some already known particle and so named them as alpha particle or helium-4 nuclei. The second is beta particle or electron, and the third is gamma ray as a form of electromagnetic radiation. The next is the ionizing and penetration power of radiation. By comparing only the three common types of ionizing radiation, alpha particles have the greatest mass. Alpha particles have approximately 4 times the mass of a proton or neutron and approximately 8,000 times the mass of a beta particle. The next is beta particle. Beta particle is much smaller than the alpha particle. Therefore, it have much less ionizing power, which has less ability to damage the tissue. But the small size give them much greater penetration power. Most researchers say that the beta particle can be stopped by a 1/4 inch thick sheet of aluminium. However, the greatest danger occur when the beta particle get inside of you. The next is gamma rays. Gamma rays are not a particle, but a high energy form of electromagnetic radiation. Gamma rays are energy that has no mass or charge. Gamma rays have tremendous penetration power and require several inches of dense material to sheet them, like lead. Gamma ray may pass all the way through a human body without striking anything. They are considered to have the least ionizing power and the greatest penetration power.
For the objective of studies on focus topic, basically we have 6 main objectives. So first is to explain and define nuclear chemistry. Second is to explain the relationship between nuclear methods and chemical physics. Third is to define mass spectrometry and explain how mass spectrometry works. Fourth is to define the X-ray and understand how X-ray work. Fifth, to explain how might the other ion be detected. And the last objective is to explain the detections of radioactivity and its devices. So, for the methodology, we as a group had been choosing a conducted exploratory research as our method of finding information and also resources in order for us to complete our assessment. Conducted exploratory research as our best method really bring us a lot of advantages as a researcher. This method of finding is very flexible, which every details in finding resources are freely and not structured under any rules as long as the data resources are genuine, authentic, and also have a quality. It is also low cost and also enable us as a researcher to make a compare and contrast between the resources in order for us to maintain the value, the quality, and also supporting details on analysis, the theory, and the fact that related to our topic. Based on our preferences while undergoing the research, the secondary research method had been the best method for us to complete our assessment. Secondary research method is gathering information from previously published primary research. In such a research, we can gather information from any resources such as journal, book, magazines, article, and so on. So, under the secondary research method, we have been using 2 methods, which is literature research and also online research.
Free electron laser is a relatively exotic type of laser where the optical amplification is achieved in an undulator fed with high energy electron from an electron accelerator. These devices have been shown with emission wavelength reaching from terahertz region to the X-ray region by the far and near infrared, the visible and ultraviolet range, even though no single device can span this entire range of wavelength. All electrons are initially distributed uniformly and only emit incoherent spontaneous radiation. They drift into micro bunches separated by a distance equal to 1 radiation wavelength through the interaction of this radiation and the electron's oscillation. All electrons begin emitting coherent radiation in phase through this interaction. All emitted radiation can perfectly reinforce itself by always superimposing wave crest and wave through in the best way possible on each other. This leads to an exponential increase in radiation power release, leading to high energy beam and laser-like properties.
If you want to know how X-ray works, let me explain. Energy was emitted in the form of X-ray, which is a type of electromagnetic radiation with higher energy than visible light and lower energy than gamma rays. Our bones are dense and full of calcium, which has relatively high atomic number, so they absorb X-ray pretty well. Soft tissue, on the other hand, is not as dense and contains mostly lower atomic number elements like carbon, hydrogen, and oxygen. So, more of the X-ray penetrate tissue like lungs and muscle, darkening the film. When X-ray travel through the body, they can interact with many atoms along the path. What is recorded on the film reflects the sum all of those interactions. X-ray are also used in type of computed tomography called CT scan used in medical treatment. This imaging technique uses up a highly detailed picture by taking X-ray image from different angles to give a series image, cross-section or slice through the part of the body being scanned.
So, next application is mass spectrometry. Firstly, I am going to talk about the concept of mass spectrometry. So basically, the concept of nuclear method in mass spectrometry is related to the atomic mass of an element that is used as a sample to measure and also detect the presence of various isotopes in that sample element. This device is designed around the idea of isotope. But what is isotope? Isotope is actually an element that have the same number of proton and electron but have slightly different in the number of neutron, which means that they have a different mass. So next, I am going to explain about how mass spectrometry works and the process that include in this device in order for us to identify the various isotope presence in that sample element. So first, we are going to put the sample element here. And this bunch of sample element will be heated up, and we will also beam it or bombard it with a bunch of electrons at the second phase. When the electron bombardment does happen, it will knock off the electron from the atoms of your sample element and ionization is happened. And by ionizing some of these atoms, they now will have charge. Because they have charge, now they can accelerate through these electric plates in the third phase. After that, this ion will move quite rapidly through this chamber and enter into the magnetic field. This magnetic field then bends the path of the ion, which means it deflects the ion. The deflections of this ion is actually affected according to its mass and also charge. For the given charge of the ion, the force of deflection will be the same, but you need to remember that mass difference is also a factor that affect the deflections of the ion. So for an example, if you have a larger mass, the deflection will be less. And contradict with that, if you have a lighter mass, the ion will be deflected more. The concepts of physics, which is force and also motion, is also applied in these deflections of ion. So if you want to calculate the deflection of ion, you can use this formula. Different isotopes being deflected different amount as they go through to the magnetic field, which at the end we can finally identify the various isotope presence in that sample element through the chart or graph with the atomic mass as a x-axis and relative abundance as a y-axis, like this. So here we can see Atomic mass play a big important role in mass spectrometry in order for us to identify the various isotope presence in sample element. So in conclusions, there are 5 phases in this mass spectrometry, and overall we can see that there are an applications of nuclear methods in this chemical physics, which is mass spectrometry.
The next is detection of radioactivity. Radioactivity can be detected by using radioactive tracer. Radioactive tracer, also known as radio labeling, radio tracer, and radioactive label, which is one form of isotopic labeling. Batch dosimeter. These batches are used to monitor the extent to which the individual has been exposed to high energy radiation. The radiation dose is determined from the extent of fogging of the film in the dosimeter. Monitoring the radiation in this way helps prevent overexposure for people whose job requires them to use radioactive material. Geiger counter. The operation of the Geiger counter is based on the ionization of matter caused by radiation. The ions and electron was produced by ionizing radiation permit conduction of an electrical current. The basic Geiger counter consists of metal tube filled with gas or argon gas. The cylinder has a window or a thin window that can be penetrated by alpha ray, beta ray, and gamma ray. In the center of the tube consists of a wire that connected to one terminal of a source of direct current. The metal cylinder is attached to other terminal. The current will flow between the wire and metal cylinder whenever ion produced by entering radiation. The current pulse also created when radiation enters the tube is amplified. Each pulse is counted as a measure of the amount of radiation. The function of Geiger counter. The first is particle detection. It detects the alpha and beta particle. For alpha particle and low energy beta particle, the end window type of Geiger tube has to be as these particles have an emitted range and are easily stopped by a solid material. Therefore, the tube requires a window which is thin enough to allow as many as possible of this particle through the filled gases. Alpha particle can be detected as the window should ideally be within 10 mm of radiation source due to the alpha particle attenuation. However, Geiger tube produces a pulse output which is the same magnitude for all detected radiation. So, a Geiger counter is an window tube cannot distinguish between alpha and beta particle. A skilled operator can use varying distance from a radiation source to differentiate between alpha and high energy beta particle. Some beta particle can also be detected by a thin wall windowless Geiger tube, which has no end window but allows high energy beta particle to pass through the tube walls. Although the tube walls have a greater stopping power than a thin end window, they still allow this more energetic particle to reach the filled gas. End window Geiger counter are still used as a general purpose portable radioactive contamination measurement and detection instrument, following to their relatively low cost and their relatively high detection efficiency, particularly with high energy beta particle. The next function of Geiger counter is to detect gamma radiation and X-rays collectively known as photons. However, detection efficiency is low compared to alpha and beta particle. For high energy photons, the tube relies on the interaction of the radiation with the tube walls, usually a high material such as chrome steel of 1 until 2 mm thickness to produce electron within the tube wall. This enter and ionize the filled gas. A chrome steel Geiger Mueller tube is about 1% efficient over a wide range of energies. The last function of Geiger counter is neutron detection. A variation of Geiger tube is used to measure neutron. where the gas used is boron trifluoride or helium-3, and a plastic moderator is used to slow the neutron. This creates an alpha particle inside the detector, and thus the neutron can be counted. Nuclear chemistry is the subdiscipline of chemistry that is concerned with changes in the nucleus of elements. These changes are the source of radioactivity and nuclear power. Chemical physics deals with the study of electron, nuclei, atom and molecule, and their interaction between them. Radioactivity is the act of emitting radiation spontaneously. This is done by an atomic nucleus that is unstable. It wants to give up some energy in order to shift to a more stable configuration. Too many protons in a nucleus lead it to emit a positron, positively charged electron, changing a proton into a neutron. Too much energy leads a nucleus to emit a gamma ray, which discards great energy without changing any of the particles in nucleus. Too much mass leads to a nucleus to emit an alpha particle, discarding 4 heavy particles, 2 protons and 2 neutrons. Chemical physics is concerned with the application of the concepts and theories of physics to the analysis of chemical systems and their physical behavior. The application of nuclear method to chemical physics are mass spectrometer, X-ray emission, free laser electron, and radioactive tracer, such as batch dosimeter and Geiger counter. One application where Geiger tubes are still in use today is in borehole gamma ray logging in holes penetrating uranium deposits. There, the gamma radiation level is so high that the inefficient detector is an advantage, avoiding the saturation overloading effects in more efficient detector. These radioactive tracers are used due to its advantage. However, it also have their disadvantage.
So this is the references that we use to complete our assessment. That's all from us. Thank you.